Hi there. In this unit, we will learn how to perform matrix multiplication in Java. Matrix is an array of numbers or symbols which are arranged in rows and columns. Matrices have wide range of applications. Applications of matrices range in physics and electronics as well. We can perform several arithmetic operations with these matrices. Before we work out matrix multiplication program, let's learn how to multiply matrices. To perform matrix multiplication, matrices must satisfy a condition. Number of columns of first matrix must be equal to number of rows of the second matrix. Now, steps to perform matrix multiplication are: multiply the elements of each row of the first matrix by the elements of each column in the second matrix. Add product result and place value in output matrix. Repeat steps for other rows and columns. Result matrix will have same number of rows as the first matrix and the same number of columns as the second matrix. Now, let's apply same logic in our example Java program. Declare a public class, matrix. Here, we will get input from user. Hence import scanner class. Now, start main method. Declare integer variables. Here, row 1 will hold number of rows in first matrix. Col1 will store number of columns in first matrix. Row 2 will have number of rows in second matrix. Col2 will store number of columns in second matrix. Declare and initialize variable sum with value 0. Also declare row index, colindex, and variable I. Here, row index will store row index of matrix. Colindex will represent columns index of matrix. Now, get number of rows and columns in first matrix from user. Create an object input for scanner class. Also, prompt values from user. Now, get input from user. Store values in row 1 and col1. Next, create a two-dimensional array, first mat. We have rows and columns as values in row 1 and col1. Ask user to input elements in first matrix. We have first element in first mat will be stored in first mat of 0, 0. That is, row index is 0 and column index 0. Next element will be placed in first matrix 0, 1. Here, you might have noticed, index of column is incrementing by 1. After completing column indices, we will move to index first mat 1, 0. Here, row indices will be incremented by 1. Next, create a for loop with initial value of colindex equals 0. Specify condition as colindex less than col1. Also, increment colindex by 1. Thus we have for loop to move along column indices. In order to move along row indices, place a for loop above our current for loop. Initialize row index equals 0. Specify condition as row index less than row 1. Also increment value in row index by 1. First, our program will enter our parent for loop with value row index equals 0. If condition stands true, program will enter for loop inside our parent for loop. Specified condition, index less than 1, will be checked. If condition results true, first input element will be stored in first mat of 0, 0. Next, loop will increment value of index by 1 in next iteration. Now, value of index is 1. Inner loop will iterate till condition index less than 1 is true. Assume we have first mat with rows and columns as 2 by 2. Here, elements will be stored in first mat as first mat of 0, 0 and first mat of 0, 1 in 2 iterations from inner loop. Next, parent loop will increment value of row index. Thereby elements will be stored in indices 1, 0 and 1, 1. Thus, we have successfully added elements to our first mat. Now, perform same operation to get elements of second mat. Just copy-paste previous operation and change row and column variables as required. Make sure you replace variable row 1 to row 2. Also, col1 to col2. Here, elements of second matrix will be stored in two-dimensional matrix second mat. Next, place condition to check if col1 is equal to row 2. Matrix multiplication is possible if col1 is equal to row 2. Also, print message if col1 is not equal to row 2. You can even place these codes in try-catch block. Let's move to else part. Declare a two-dimensional matrix result mat. Result mat will store multiplication result of first mat and second mat.